brief overview of the RETScreen software that I'll provide right now. Gregory J. Lang, who's the creator of RETScreen and the director of RETScreen International, is going to do a live demonstration on the new RETScreen Expert software. So what is RETScreen? RETScreen is essentially software that allows the user to determine whether or not a proposed renewable energy, energy efficiency, heating and cooling, or cogeneration project makes financial sense. If the project is viable or if it is not, RETScreen helps the decision maker understand this quickly, unequivocally, in a user-friendly format and at relatively minimal cost. You'll see on the bullet points above that the software is available in 36 languages, covering 2/3 of the world's population. At present, we have over 465,000 users in every country and territory of the world. The software is growing at a rate of about 30,000 new users every year. A large number of universities and colleges are using RETScreen for teaching and research. And we estimate that RETScreen has been responsible for well over $8 billion in direct user savings since the first edition of the software was made public in 1998. This particular webinar is going to be demonstrating the new RETScreen Expert software, which is currently being beta tested and is scheduled for public release in October. If you are interested in beta testing the new software, you can contact us through our website, www.retscreen.net. It's up at the upper right-hand corner of the screen there. And what we'll do is add you to our list of beta testers who will receive a copy of the software towards the end of May. For now, though, the internationally known and very well recognized RETScreen Suite is available for immediate use. You can download the software right after this webinar by going to our website. The software is free of charge and you can download it in the language of your choice. I want to stress that the stats that I've outlined here on the screen, these are for RETScreen Suite, so you don't have to wait for RETScreen Expert to start achieving real results. In fact, starting to use RETScreen Suite is going to give you a real head start on using the new software, RETScreen Expert. So we do encourage you to download the software if you don't already have it. This graph is just a snapshot indication of how RETScreen has become the most widely used software tool for clean energy project and performance analysis. It very quickly depicts RETScreen's growth, which I mentioned is more than 30,000. It's probably well over 30,000 new users every year. RETScreen has really become the de facto global standard for clean energy analysis, whether you judge it by metrics of market penetration, use by key organizations, including governments, private sector, and academia, and of course, energy and money saved. RETScreen is used by many, many more people than all other clean energy analysis software combined. We estimate roughly double the number of all the other softwares combined. And you'll see on the right-hand side of the slide there just the top 20 countries in terms of RETScreen use, and all the largest economies of the world are represented there. So it just gives you an example of how RETScreen really has become sort of a universal software tool for clean energy analysis. And finally, this slide shows the home screen of the new RETScreen Expert. So RETScreen Expert is the next generation of the RETScreen software, and as mentioned, it's scheduled for public release in a couple of months. In October, it'll be available on our website. RETScreen Expert has been funded primarily by Natural Resources Canada, with important contributions from partners including the National Aeronautics and Space Administration in the US, NASA, the Renewable Energy and Energy Efficiency Partnership in Vienna, and Ontario's Independent Electricity System Operator. So the best way to understand RETScreen Expert is to see it in action. You are actually one of the first groups to actually see the software demonstrated live. So I am now going to stop talking and let Greg give you a live software demonstration. Greg?
Okay. Thanks, Dinesh. Just want to confirm, Dinesh, can you see my screen with the software showing?
Yes, I can.
Okay, great. Okay, so welcome everybody, and also thank you to CESC and NREL for inviting us to make this presentation. The CESC service, I think, is an excellent service. that NREL and its partners are providing. Okay, so today I'm going to be presenting the new RETScreen Expert software that Tanisha mentioned is currently in beta testing. Will be released to the public in October, but we will expand our beta testing at the end of May. So for those that are familiar with the current versions of RETScreen, which is RETScreen Suite, within RETScreen Suite there's a product called RETScreen 4, which is a feasibility analysis tool to determine does your renewable energy, clean energy, energy efficiency project make financial sense. Then there's a RETScreen Plus product, which is your measurement verification or your monitoring tool to actually track the performance of your investments over their life cycle. So those are available in RETScreen Suite. Today, as we're showing in RETScreen Expert, there are sort of three major new upgrades to the software, to the RETScreen software package. One of them is that those various modules, feasibility analysis, performance analysis, and a new benchmark analysis module, they've all now been integrated into one software platform. And this software platform now is a Windows.NET platform, no longer linked into Microsoft Excel, etc. So that has been a major component, is integrating all the software into one software platform, available in 36 languages. Second major component is we've developed what we call a virtual energy analyzer, and this allows you to do rapid energy modeling or remote energy analysis without having to visit the site to get do a quick feasibility analysis or a quick energy audit of a facility to basically get an idea, does the project potentially make sense, and then if so, you adapt and adjust your analysis with more on-site information, etc., and refine your analysis as you move forward. So I'll demonstrate that through a live example of a project in China. And then the third major component of the new version of RETScreen, which is RETScreen Expert, is what we call My Portfolio. And so it's a portfolio analysis tool. And what it does is it takes all of your different analyses of, for example, wind farms and or power plants or buildings and factories, etc. And if you own multiple facilities or are looking at multiple facilities, you can combine them all now into this one tool called My Portfolio, where you can manage all those, your portfolio of facilities and projects, and you also can analyze them and look at the overall impact from climate change or greenhouse gas mitigation perspective, financial returns, energy savings, etc. You can do that all through this new My Portfolio tool. All right, so today we're really trying to answer the question, does our clean energy project or projects make financial sense? So we're going to focus more on the financial aspects of projects today rather than the detailed technical aspects. So looking first at the platform and the workflow of doing an analysis, the RETScreen Expert is made up of three key modules. There's one which is a new benchmark analysis module, where you can benchmark your facility, such as a commercial building or a hospital or a school, for example, and how it compares to other similar facilities. It's a standard benchmarking, or you can also enter your own benchmark information if you want to compare it to corporate standards or targets that you want to set. Okay, and within the benchmark module here, there are separate worksheets. The first worksheet is the location worksheet, and the second one is a facility worksheet. And you can see those actually at the top of the screen going from left to right. So, for example, the location worksheet is where information about where your project is located, climate information, etc. And then facility is information about your facility, etc. So you access the various worksheets at the top of the screen, as I'm just doing there. So I'm going to go back to the file home here. Okay, so that's the benchmark analysis module. So once you've done a quick benchmarking, how does your facility look? You then can move into feasibility analysis, which is going to be a more detailed analysis than basic benchmarking, where you're going to go in and look at, how much energy does your wind farm produce, or how much energy can you save in your energy efficient or green building, for example. And that's through you do your energy analysis on the energy worksheet highlighted here, and then you can summarize and do more detailed cost analysis if you want in your cost sheet. Then there's emissions analysis, where you do your standardized greenhouse gas emissions analysis. Then there's a financial analysis, where you determine the financial viability of your project, calculating things like internal rates of return and simple payback and net present value, etc. And then there's the risk analysis, and that's where you do a more advanced analysis and sensitivity analysis, where you're trying to look at various different uncertainties in your analysis and try to predict future returns in different scenarios. So that's on the financial feasibility side. Then the performance analysis module, and those that already know RETScreen, that would have been what you've recognized as RETScreen Plus. This is our measurement verification or monitoring, targeting, and reporting tool, and that's to allow you, once you've built your facility or installed your individual projects, that you can then measure and verify over the life of those facilities. Are you actually getting the performance that you expected? Are you getting the returns and the energy savings, for example, that you expected, the cost savings, etc. All right, and that's made up of a series of worksheets. Again, there's a data worksheet, and that's essentially a database that allows you to collect data such as how much natural gas you use, how much electricity, and also other parameters that are correlated with that, such as weather or climate data, weather data, things like heating degree days, solar radiation, etc. So that's stored and filtered and in the data analysis worksheet. Then there's an analytics worksheet where advanced regression models are used to create predictive models that take into account and normalize your energy performance based on varying parameters such as weather or production in a factory, etc. And then it links in then to a reporting tool where you report your results to decision makers and facility operators, etc. And one of the key things here, as you see, is the circle. So the idea is once you report, is then you compare your results to benchmarks again. You continue to set over the life of a facility, continue to look for more and more ways to reduce energy consumption, reduce greenhouse gas emissions, save money, etc. And it's a continuous process, including recommissioning of facilities, etc. So that's depicted in that workflow there. Okay. Now I mentioned some different types of facilities that the software can be used for. So RETScreen can be used, and this module or this new version of the software can be used for various types of power plants, such as very large combined cycle steam turbine plants and coal plants even, hydro, wind, photovoltaic, solar thermal power, etc. And then on the buildings factory side, it can be used for all sorts of industrial facilities. Same on the commercial institutional side, commercial buildings, institutional buildings like schools and hospitals, etc. On the residential side, such as apartment buildings and houses. On the agricultural side, you can use for analyzing greenhouses and chicken coops, for example. Or you can do your own user-defined analysis. So, for example, it might be street lighting, or in this case, lighting of piers or sidewalks, etc. And in addition to being able to do a full facility analysis, you can also use the software for just specific individual measures, such as solar water heaters or just lighting replacements or pumps and motors, fans, any individual measure that you want to look at. And of course, the software can be used for both new construction, and it can be used for existing facilities. And this picture is quite good because it shows the concept of before and after, left side to right side, base case, proposed case. What do you have now and what do you want to do? In this case, they were improving the building envelope of that building. All right, so that's just to give the concept of doing basic financial analysis. Integrated in with it, within the software is some key features that you should be aware of. So one is a user manual so basically for every cell in the software, so I'm going to move my cursor here. For example, I'm moving it over the term getting started -options. So if I click on that, when you see the little help button appears next to the cursor, if I click, it opens the user manual specifically for that topic. So that's a great way to quickly understand what's going on in the software and if you want to learn more details about any section. We also have a product database of over, I think we're approaching 50,000 different products, from power products, heating, cooling, pumps, motors, and lights, and etc. So that product database continues to be updated and improved. We've built in a new cost database of what various energy efficiency measures cost, etc., or renewable energy systems. So that will show live in the software. There's a benchmark database of the typical benchmark facilities around the world. And there's a climate database, so I'll just click on that just to show you. So we have in the RETScreen software 6,700 ground stations around the world, and those are represented by the red dots there. Those are typically airports or military bases, etc. And then for communities around the world which do not have a ground monitoring station, we then supplement that data with data from NASA satellites, which provides the climate data. And so, for example, if I click on the map and move it, and say the project is located right where that little house icon is, the software will automatically find the closest station for you and tell you the distance to each station, and you can change them if you can change stations if you want. Okay, so it's an extremely valuable tool, and that's a global tool. That's for across the globe. We have climate data. Okay, so that's a very valuable tool in the software. We also have weather data. So climate data is long-term averages. Weather data is what happened yesterday, basically, or today. And weather data is used when you're doing your measurement verification and your ongoing performance. And so with our collaboration with NASA, we can actually stream near real-time data from NASA satellites through their large computer systems directly into the RETScreen software. So that's an extremely valuable tool. And then there's a new tool called the Feasibility Analysis Dashboard, and that I will show in a few minutes during my demonstration. Okay, so let's get right into doing a demonstration now of the virtual energy analyzer, and let's do a project. So I'm going to click, and this is a great way if you're doing benchmarking and feasibility analysis, or even if you're doing more detailed performance analysis. It's a great way to start within the software if you're starting an analysis of a facility for the first time. So I click on the virtual energy analyzer, and so it opens again the big map, and the basic concept here is that by answering basic 3 or 4 questions. So what type of facility are you, with a bit more detail, and where are you in the world? Just with that basic information, the software will be able to provide you with a rapid analysis, a feasibility analysis, depending on the type of facility and where it is, and a relatively accurate analysis to get you started, rapidly get you started on a more refined feasibility analysis, energy audit, etc. The idea is to get you anywhere from 50 to 90% where you need to go in doing your analysis to significantly save you both time and money, and improving the accuracy of getting to the right answer. So, for example, so I mentioned earlier for power plants. the software can be used for various types of power plants. So for photovoltaic, wind, gas turbine, combined cycle, etc. Steam turbines, and then with biomass fuels, etc. But what we're going to, the other types of facilities again are industrial. So this virtual energy analyzer is made up of a database of archetypical facilities, and within those that database, we have varying levels of details, but what you see is 5-star ranking of any archetype here is we've actually gone in and done the base case energy analysis. We've done the proposed case of what are some of the things that you can do for the facility, and we've actually done the incremental cost analysis, and that's what we, in this case, we call a 5-star archetype. And so, for example, under industrial, we've so far built up some key industrial facilities where we've done both the base case, proposed case, and incremental cost analysis, and of course the software can be used for all sorts of other types of industrial facilities. Okay, and then the same thing on the commercial institutional buildings. So for example, education, we have archetypes for elementary or high schools. Same thing for like food retail, grocery stores, food services, both quick service and full service restaurants, healthcare facilities, outpatient clinics or very large hospitals. These are all what we call 5-star archetypes, where we actually have the full analysis done for you. Hotels, large and small, etc. Okay, and then the same thing when we come. Same thing for residential, for apartment buildings, and then we're working on ones for housing, etc. And then agriculture, right now we've built up a couple for greenhouses and poultry, and we'll continue to expand that. All right, so let's go in just today as an example, as something that could be applicable to many of the people in the audience today. So let's take a look at an office building. And in this case, let's do a medium-sized office building. And we're going to look at doing energy efficiency in that and a bit of renewables, etc. And let's assume that building is in Suzhou, China, just outside of Shanghai. I've done a bit of work there, so I've chosen that as an example. So I'm just going to double-click here, and it automatically brings me to Suzhou, China. I'll just zoom out. You can see Shanghai is right here. So you can see where it is within China, and I'm just going to zoom in, center it. I'm just going to center again using this feature and center it right to where I clicked. Okay, so let's go in and let's find a building. So I'm sitting here in my office near Niagara Falls, Canada, looking basically live at doing a project in Suzhou, China. And let's go in. I remember seeing there was a football stadium. It's right here. Okay, so I remember there's an office building. I stayed right near there. Okay, so there's an office building right there. So we can, again, here I am remotely going in, looking at this facility, seeing the sort of heating ventilation equipment on the roof, and that's it. I've just chosen 3 simple parameters, and where are you in the world? I'm now going to hit calculate. So I hit calculate, and I'm not going to save what I did before. So now the software, the decision engine is calculating, it's gathering climate data, it's gathering cost data, it's gathering product data, and boom, it's done. It's now done a feasibility, a pre-feasibility, or quick energy audit for that facility in China. And then the idea now is I can go through and adapt it and modify it to more accurately predict the potential energy savings and the financial returns for that facility. So let's just go through now over the next 15 to 20 minutes or so, just going in and taking a look at how that analysis was done and how we get to determining is this a financially viable project. So again, we're looking at this mid-sized commercial office building. So the software automatically brought us to the location page. So this location page is where you have your key information about the facility. So the map is brought here. You can zoom in if you want into the map and change the street view if you want, etc. So it's just show the flexibility in the software. Okay, and the software using the RETScreen Climate Database has gone and gathered all the climate data. It's also gone in and gathered climate zone information or calculated climate zone information for that facility. And in this case, we're seeing that the source of the data is NASA, and the reason is that that there actually is not a ground monitoring station available there, and so in this case, we're using NASA satellite data to calculate our heating or weather-dependent variables, or climate-dependent variables in doing our analysis. So the information is brought in to the software. You can always modify it if you want, but this is from our database, and including things like as the blue bars here are the solar radiation available. The green line is the average temperature of that facility. You can do precipitation, for example, if you want. So this is just this tool alone here is extremely valuable when you're doing energy analysis of a facility. Okay, so there's not much we do there. The software's done it all for us. So we have all the climate information. So let's go now over to the facility information. This is the facility worksheet that I'm clicking on at the top of the sheet. So the software has gone in and again filled in everything automatically for you because I use the virtual energy analyzer. I want you to take note of the ribbon at the top of the software. That's very much like a wizard. If you follow the steps at the top, it makes it quite straightforward. But I want to note here when you use the virtual energy analyzer, the virtual energy analyzer is actually filling in most of the cells for you, and then you just simply need to modify them. So for example, just so we understand the color coding for the software, so yellow cells are user inputs and required by the user to run the model. White cells are output calculated by the model. User can't change them. Blue cells also are required to run the model, but there's a database available from RETScreen, such as product data or cost data, that will help you fill it in. And gray cells are just for user information. So for example, we're preparing this for the CESC webinar, and it's prepared by CanMet Energy, just to give you an example of how you could use that. All right, and then facility name right here, let's say it's ABCD Corp, the head office. All right, so that's just basic information. Using the Bing map, it knows that we're already in China. We built in a series of additional input parameters if you'd like. So if I click on here, you can actually go in and add much more information about that company and who's doing the software, and this all gets added into the database of the software, so you can use that over and over. You can also modify the images if you like and put your own photos in. All right, so that's just basic keeping information available for your facility. Now, the next section, which is the step 2 here, is the benchmark. So this archetypical facility is 4,500 square meters. You can, of course, use imperial units if you want, but we'll stick to SI units right here, metric. So basically is the facility size. You can determine when you're looking at energy use intensity, you can of course change your energy units. So the software automatically has gone into the benchmark database and gathered, so for a typical office building in the US, we're using US as the baseline is for the basic benchmarking is 293 kilowatt hours per square meter, plus a range of values for average of typical benchmarks. And then the base case is for your facility. So the software has actually gone in, because we use the virtual energy analyzer, it's actually gone in and modeled that building already and come up with a base case energy use intensity for that facility. And through a series of proposed cost-effective measures, it's come up and calculated that the software can reduce 25% of that consumption, and we'll show how that's done. So that's a quick benchmark analysis, and each of these values, of course, can be changed by the user. You might have your own benchmarks that you want to set. It might be a corporate benchmark. You might want to change your targets. So, for example, the base case and target is shown over here. So, for example, you might want to set a corporate target, and I could just drag the target on this graph. So, you might want to get to a 50% energy reduction. That might be a corporate target, or you might even go down to a net zero target of no net energy consumption basically at the facility, and this is where renewable energy would come into play. But we'll stick to the 25% target here. That's just to show you how easy it is to do benchmarking and targeting for a facility. All right, so that's it. The benchmark analysis is done for you. Again, so let's now go to the energy modeling, which is more detailed. So again, because we use the virtual energy analyzer, the software has gone in, it's actually run a feasibility or an energy audit for this archetypical facility in Suzhou, China. And then we can now go in if we want and begin to modify some of the parameters, etc. But first I want to show you the structure. So and you'll see that along the ribbon. So first you identify your types of fuels and any schedules you have in the building. Then you'll go in, you define your heating and cooling equipment, what type of heating systems you have, etc., cooling systems, and the manual to support that. Then you go in and define your end use. And so as I go across the ribbon here, you also see it's the same structure as I go down the left menu here. So for example, you go in and define your building envelope and your lights, and you might have process heat, process steam, compressed air, etc. So these are end use. Again, the manual can support that. And then for step 4 is you might want to optimize supply. So in addition to your standard efficiency measures, you might want to come in and add solar air heating, solar water heating, for example, or go in and add some renewable energy to help you get closer to your net zero goal, for example. And then the step 5 is really your summary, and this is where we are right now. We're in the step 5, which is the summary view of all the analysis. So the software did all the analysis for you. And it's summarized by key parameters. So how much fuel saved, both electricity and other fuels, or you can also look at how much base case energy is used or how much proposed case energy, but we'll focus on the savings at this point. And then it breaks it up by both for heating loads, for cooling loads, and for electricity loads or things, plug loads, etc. And then what are the incremental costs, which the software automatically goes in and calculates, and the user can modify. And then the fuel cost savings, also incremental operation and maintenance savings or costs. And then a quick calculation of simple payback to give you a basic idea, and then you can do more sophisticated financial analysis after. And then this column over here on the right, which is basically this becomes your energy plan for your facility, and then you can tick these boxes and turn on and say, okay, I want to do this. If I untick it, so for example, right now we have solar water heating and photovoltaics that are unticked. We'll come back and look at those after. So right now they're not in this plan. Okay, and so we can see down at the bottom, it shows us the total heating savings, cooling savings, electricity savings, and then how much all that would cost, the cost savings on an annual from a dollar or monetary perspective, and then those know how to calculate simple payback. It's just quite simple. It produces a 6.1 year simple payback for this facility. All right, so just to see now how you can zoom in and begin to do and modify a more detailed analysis. So for example, let's take a look at lights. So within lights there's various type of lighting in offices, in the cafeteria, outside parking, etc. So I'm going to click here on office, and it's going to bring me to the light form, and you can also see it on the left menu over here. All right, and I can navigate between various forms there as well. But we're going to look at the light in the office. So in the base case, we had fluorescent T8 as assumed in the archetypical facility, but you very quickly can change it to any other sort of base case lighting that you might have in your facility. And then the proposed case, we're proposing here light-emitting diodes, which are rapidly expanding globally as an energy efficiency measure. But there's various other type of lighting systems that you can put in depending on the end use. If a hockey arena is going to use different sorts of lighting, for example. Okay, and there's we also have built-in databases too. If you don't want to use our generic values, you can also go in to individual manufacturers and use their product data. So there's various base case, proposed case information entered about the lighting, how many lighting fixtures, et cetera, and how many hours a day they're used, and also the life of the lamps, et cetera, which is a key parameter. And so for example, I mentioned there is a new RETScreen cost database. So if I click here, this actually opens the new RETScreen cost database, and it's specific to each technology. So we have one for pumps, one for photovoltaic modules, et cetera, et cetera. So this is for light. So it gives you typical lamp costs, installation costs, and also hours for various different types of facilities. And then you pick and choose which one you want and hit go, and the values get pasted into the software. So it's a great starting point if you have no information on cost or if you want to check or refine. Okay, it's extremely valuable that way. And in the end, basically we're interested in both the energy and the cost savings, and ultimately the greenhouse gas savings as well. So on the electricity side, the base case lighting load on an annual basis here for the offices would be roughly 92,000 kilowatt hours. And in the proposed case scenario, it would be 46,000 kilowatt hours. So basically there's a 50% savings by going to the light emitting diodes. Another important parameter here, and that often gets forgotten when people do analysis of facilities and buildings and factories, etc., is they forget the heating and or cooling impact of the efficiency measures that they're implementing. So for example, if you put in more efficient lights, you're actually going to have less waste heat available in that facility because your lights are using that energy much more efficiently. And so that waste heat, if you increase the efficiency of the lights, you have less waste heat available. That's going to help you on your cooling loads. It's going to reduce your annual cooling load requirements. But on the other hand, it's going to increase your annual heating load requirements because you're going to have less waste heat off the facilities. And depending on where you are in the world, that can actually be a pretty significant value. So it's important to consider also this dynamic impact of individual measures such as lighting on the overall system. And the RETScreen Analysis Module software does that for you. So I'm going to go back to the summary page. So those results are just summarized here. And then you calculate the simple payback for each measure, etc. And just to show how the same approach, same process is done for other measures, other pieces of equipment, for example. So for example, we look at motors for the elevators in the office building. It's the exact same user interface. The only difference is now we're dealing with motors and size of motors and RPMs of motor, etc. And the base case using standard efficiency, energy efficient or premium efficiency motors, or you can do a user-defined and use a motors database to calculate the values. And the same thing, there's also the heating and cooling impact of putting in more efficient motors. All right, so same approach throughout the software. Okay, so that was a very basic financial analysis of a archetypical mid-size office building in Suzhou, China. So you can do a series of measures, roughly get a 6.1-year payback, and you can see the details on each of those if you want. So let's continue to move now through the RETScreen software, so we can look at other aspects such how do we do a more detailed financial analysis, for example. So there's a cost analysis worksheet where your costs are summarized. You can show the details from the previous sheet of each individual measure. Or if you want, you can get very detailed to level 3 and zoom right in and do a very detailed cost analysis if you want. But we're going to keep it a bit more simple today. It just shows you how you can go from higher level 1 down to deeper levels and deeper level of analysis over time using the RETScreen software. Software automatically calculates the greenhouse gas savings for you. This is work we've done with the UN and the World Bank. It knows here in China it's used as emissions factor for the savings for the facility. So that those measures that we just did is equivalent to about 20 North American cars taken off the road, or about roughly 25 acres of forest absorbing carbon. So and you can do carbon trading if you want by putting a carbon price in the cell down here. Okay, on the finance side, now we get more details. So going from just a simple payback calculation, which is it's simple, it's easy to use, that's why people use it. It's a starting point. But if you want to get into really promoting and deploying clean energy and helping governments and organizations, private sector, public sector organizations identify financially viable projects, you need to make your financial analysis a bit more sophisticated. Because often, for example, a 6.1 year payback, as was calculated in the software, if that's a company, that might actually be too long. It's okay for a public institution like a school or a hospital, but companies might have a shorter payback requirement. But that same project, 6.1 year, which is highlighted here, it actually has a pre-tax internal rate of return of 34%. That's basically a return on investment of 34%, which is far greater than any return you're going to get by putting in bonds and investment in this, even in the stock market. So a project might get rejected with a 6.1 year payback, when in fact it's actually a excellent financial investment for the organization. So this is why we moved to a more sophisticated financial analysis in RETScreen to actually help decision makers find these viable projects and implement them over time. Okay, so again, the software has gone in and automatically done the financial analysis for you. The user can go in and change the values, such as inflation rate or whatever values they want. It goes in and assumes 70% debt, meaning you're financing 70% of the project, putting 30% of the money down yourself, and the interest rates. But you can modify all of those, and then the cash flows for the projects are shown here. And so you can see that after the first year you spend money to implement the project, but then it's a series of positive cash flows, and then in this year when your loan is paid off, the cash flows improve even more. All right, and we can do more sophisticated things like income tax analysis, etc. We'll show that in a few minutes. Okay, so now we've done the financial analysis. Software's done it for you, actually. Then we move into even more sophisticated financial analysis, and this is where we look at risk analysis, where we do both sensitivity and risk analysis. So sensitivity analysis is is you look at the performance parameters. So let's go back to finance for a second. So we said the internal rate of return was roughly 34%. And net present value is positive. It's, in this case, it says $74,000. So it's the project is making money. So let's just go now, and that's for a single run of the software for a single value. Now let's look at running the software many, many times and look at various different scenarios. And this is often also called due diligence analysis. So for example, let's say we're interested in looking at the parameter internal rate of return on equity. And the sensitivity range is, I just sat here remotely from Niagara Falls, Canada, doing analysis in China, so I'm guessing at some of these numbers, but using the RETScreen cost databases, so it gets us in the right range. But let's say we're plus or minus 25% in our guessing. And the threshold is also what's known as the hurdle rate. This is, what the investor will want as a return, internal rate of return on their project. So let's say, just as an example, let's say they're for clean energy projects are willing to looking for a return hurdle rate of 14%. So what the software has done is quickly run a sensitivity analysis for key parameters. So this was the 34% internal rate of return that was calculated on the finance sheet. And the idea is along the x-axis we're varying the initial cost of the projects, and on the y-axis in this case we're saying what was the base case fuel costs. So what are we displacing essentially? And of course you can change those parameters and choose whatever you'd like to look at along the axis. So for example, just to show how this works, so for example, if our project actually cost 25% more, so moving this way, we would still have an internal rate of return of 23%. So that's still a good project. And if the project actually ended up being cheaper, we'd have greater returns. Following the y-axis is what if our estimates of our base case fuel, how much fuel we use in the base case, was we actually didn't use as much in the base case, or it was we didn't pay as much for it. Therefore, we're displacing less cost savings. Basically, we see that our internal rate of return would drop to 13, and the software just highlights that for you automatically. And you can go in and add parameters. Software automatically goes in and looks at debt interest rates versus debt ratios, and in this case, you see it really doesn't have much of an effect at all. All right, so that's sort of traditional sensitivity analysis. The software does it for you automatically. And now risk analysis, this is actually much more sophisticated. It's a statistical analysis using what's called a Monte Carlo simulation. In this case, let's take a look at the net present value. It'll actually run automatically the software for 500 possible different combinations, looking at the various uncertainties in each of your parameters to help predict what your potential outcomes are, what are the return, in this case, the net present value. And in the new version of the software, we've increased that now to up to 5,000 combinations. But I won't do that here because being connected to GoToMeeting might slow it down a bit. Okay, but so for example, what if our costs, we're really guessing, let's vary that parameter by 50%. The software's now, when I just clicked that, the software just ran 500 times and repredicted the outcomes of net present value based on varying the range of these input parameters. So for example, and let's do another one. Let's say, for example, our interest rates that we pay were also maybe varying by 50%. You see the range of value changes. So what this graph here is called a tornado graph. What this is doing is actually predicting the relative impact of each of these individual parameters. It's basically telling you which ones are important, which ones do you need to focus on as you refine your analysis. And it very clearly says, in this case, that both your base case fuel costs and your proposed case fuel costs are extremely important in terms of the possible outcomes of your net present value. This is really the parameter that you need to look at, and this is where you might use our performance analysis module to really go in and look at, for example, for existing buildings, what is your actual energy consumption. And in our energy model page, we're finding your energy calculations. It's telling you those are the really important parameters to look at. Initial cost is also important, and it's telling you in this case actually that your debt interest rates and your debt turn, how long the loan is, stuff actually have very little impact, and so it's probably not worth spending much time on that in the initial stages at least. And then it also software also provides a probability distribution, and this is what banks and insurance companies will use when loaning money on a project or providing insurance on a project. They want to see, is this project going to go bankrupt? So they look at the probability distribution of essentially negative returns. And in this case, this project it's only one case where at the extreme left of this, the probability distribution, where there's potential for a negative net present value. So this has actually run the model 500 times and come up with these possible scenarios for net present value. So this, from a risk perspective, would look like a very stable project from that perspective. Okay, and just in the 4 or 5 minutes remaining for this section of the presentation, let's go in now and look at the reporting tool. So the software, we've built in an automatic reporting tool, and you can that goes in and automatically prepares the report for you. You can go in and for example, you can go in and insert your own logo, for example. I'll just give an example from File, and then go onto my desktop just to show you for example, let's say McGill University, prepared it. So anyways, it's a very rapid way to prepare professional-looking report as well. And then the software automatically prepares things like your cash flow graphs, etc. We mentioned the software is available in 36 languages. So in this case, our client is in China, so I would switch the software and the report over to simplified Chinese, and the software is going to do that all automatically. So just the cost savings in terms of doing translation of reports. You can see now the entire software is operating in Chinese, so you can actually switch that for your client. They can review it in Chinese, and then switch it back to English if they have questions, comments, etc. So it's also RETScreen is also a great communications tool among these 36 languages that we have in there. All right, so that is the sort of the overview of the sort of financial analysis and using the virtual energy analyzer. So now I want to dive a little bit deeper in the next 5 minutes or so and show you some other features that allow you to do what-if scenarios in financial analysis. So one thing I'm going to do here is open with what's called our new feasibility analysis dashboard. So I'm going to drag that right over here. So this is a really nice feature that lets you carry all the key calculations, such as these cash flows and things like that, and it's movable between sheets. So you can actually go in and do what-if scenarios and change figures and see the results. So and it has multiple views. You can do it as dynamic, large slideshows, so you don't even have to prepare PowerPoint slides. It's all done automatically. But I like this one-column view, so I'm just going to click on that. It's just loading, and what I'm going to go in just show you quickly how easy it is. I can go in and say, what do I like to see? So I could do, for example, fuel savings. How much gas, how much electricity did we save in that project? And I like to see the annual cash flows, for example. And so that that graph I can shows the gas, how much gas and electricity before and after, and this is how much is saved, and then the annual cash flows down below. So you get to pick and choose what you'd like to see. So actually what I like to see actually when I'm doing financial analysis like this is I like to see the financial viability at the top and the cash flow below. But again, you can customize the dashboard as you like. So again, remember, here's our 34% return on investment. Key parameters are summarized, net present value. So let's go back now and look at this quick energy audit or feasibility study that the virtual energy analyzer did for us. Now, the virtual energy analyzer will automatically go in and also size in a solar water heating system and a photovoltaic system. And it's usually unticked, meaning it's designed, etc., and the user can go in and decide to add these. Typically, they tend to be more costly than traditional energy efficiency measures, but they also help you reach green building standards, reducing greenhouse gas emissions, and particularly for net zero energy buildings. So for example, if I go in and tick and add the solar water heater system, well, we can watch the internal rate of return here is 34.1. If I go in and tick on that, the software, the engine, everything is being recalculated. The returns, everything's throughout the software is being recalculated there. And you can see that the solar water heating system will save about just about 10,000 kilowatt hours of heat per year, and at a cost of about $15,000. Simple payback of about 52 years, so a long payback. But if for example, if the owner of this facility says, look, we're willing to accept any green energy, clean energy project overall in any facility that gives us a return of greater than 14%, for example, or 18%. What we can do is go through and say, well, what else can we do to this facility, maximize the clean energy in this facility while still meeting our financial objectives of our senior decision makers, for example. Next thing we would do is go in and look at the photovoltaic system. Now, again, looking at the internal rate of return, looking at the cash flows over here, I hit go. So it's now taking this 59 kilowatt system that the software automatically had sized. It's roughly 20% of the roof area of the building done automatically. And you can see it actually, the cash flows all of a sudden get negative until or quite low until the loan is paid off. The internal rate of return has dropped significantly. And that's because the system relatively, it saves quite a bit of electricity in a net zero, or in a net metering situation. But the system cost is quite high, and you see that reflected in the simple payback. So just like we before went in and looked at the lighting system, the motor system, let's go in just rapidly now and look at the photovoltaic system on this facility. And let's go in and say, look, let's go a small 10 system, because we want to get as much clean energy or green energy onto that building while still maintaining our internal rate of return target set by our senior management. So we'll go in and right now it's a 59 kilowatt system. Again, the inputs, the outputs, the interface of the software is the same that we were looking at lighting before. Now this is a photovoltaic system. Let's go into the product database just to show how that works. And what I'll do is I'm going to actually choose a Canadian solar plant because they've actually got several plants in Suzhou, China. And let's go in and choose one of their modules there. Let's say a 200 watt module. Okay, so 200 watt module. And I want to do a 10 kilowatt. You can also toggle up and down if you want, but I'll do a 10 kilowatt here. It's got the efficiencies for those modules in the area, and I hit go. It's now pasted their value. It's updated the software throughout all of it. We have our cost database for power plants that's also been used. All right, and so this is interesting. So now we can still afford to do a 10 kilowatt system rather than a larger 59 kilowatt system. Still has the 42-year payback. But overall, the payback for the entire analysis is 8.6 years, and it gives a return on investment of 18.4%. Okay, so in the last minute here, that's just an example of how to use it. So how to use the dashboard. So in the last section here, let's just go in quickly and show how you can dive even deeper into the financial analysis, such as doing income tax analysis. So if this is a profit-making company, often people forget when you reduce your energy consumption, you're actually increasing the profits of your company. You're actually increasing typically your income tax on the facility, and that's usually forgotten when people do their analysis. So I'm just going to say 33%. You have different depreciation methods, etc. And let's say in China they have a 5-year tax holiday for any green energy projects. That's showing how you can also use it for policy analysis. And I hit go. And so what the software again has automatically updated, and we can see now the pre-tax internal rate of return is the same. But here now a new value has shown up, the after-tax internal rate of return is about 14.8% after you pay your income tax on that project. Okay, so we're right on time, and so what I'm going to do is I'm going to keep control of the screen, but I'm going to tell Tanisha now that we're ready to open up the floor to any questions that people, the audience, might have.
Great. Thanks very much, Greg. We'll go quickly back to the example you were just showing. There, a question came in with regards to that. And the question is, in your example, measures for space heating and domestic hot water, in your example, measures for space heating and domestic hot water were included, but all results were 0. Is this, am I misreading this?
Yeah, okay, so that's a good question. So, so space heating and domestic hot water. So that's a good question. So, so there's two things that we need to do when we do analysis. Is if we're going to do a full facility, we actually need to model the entire facility and all the different measures. So even if we don't improve the heating system or improve the cooling system, we need to model them so we can model the total impact on the facility. So we were looking at fuel saved. Okay, so we've done nothing to the heating system or the cooling system in this case. It's the same base case, proposed case for the heating system and cooling system. We could go in, for example, and put in a high efficiency boiler. I'll just show that here quickly. 80%. I could put a cost in, but for now I won't. And if I go and look now, there's actually now a fuel saving for the heating system. So that's why it was 0 before, because we were actually not upgrading the heating and cooling equipment. Okay.
Okay. Thanks very much, Greg. The next question here. This one actually came in near the beginning, but if you could just explain the basic difference between Homer and RETScreen.
Yeah, so basic difference between Homer and RETScreen. So Homer is primarily focused on sort of off-grid or mini-grid type systems, and Homer is more of a feasibility and optimization tool, whereas RETScreen is a broader use tool, so it covers energy efficiency, grid integrated systems, etc. And Tanisha, if you could just mute your mic, and that, yeah, thanks. And so RETScreen is a pre-feasibility tool. If you're looking at a off-grid system or a mini-grid in a developing country, you might, or a remote area, you might use RETScreen on the pre-feasibility side, and then use Homer to do your optimization. So often we see people using both, and Homer is an excellent software tool as well, particularly when you get into optimization and sizing and designing. But again, the other big difference is RETScreen is a fully comprehensive energy management software. So not only is it looking at power systems, but it's also looking at energy efficiency, buildings, factories, and it's looking at ongoing performance analysis, measurement, and also has a portfolio feature as well. So it's a much more comprehensive tool. Okay. Okay.
Thanks, Greg. The next question is, could you show the new portfolio tool which you mentioned earlier?
Okay, yeah, so we'll probably organize sessions later on, doing performance analysis and then doing also portfolio analysis with RETScreen. But just quickly, so for example, so as I mentioned, one facility, you do analysis for one facility, but now you can combine many facilities together. So we do that through My Portfolio. So I click on My Portfolio. So it's all within the same platform. So what we're going to do is you can open a portfolio file or create a new one. In this case, we have a sample portfolio, in this case for some projects in Ontario. So let me just click on that. I'm not going to save what I did before. So it's the same software platform. You see the worksheets at the top of the software have now changed, and it's now our portfolio analysis module. So I'm going to click on All here. And so what you're looking at is essentially a database of many different projects So we were looking at a medium office building before, but what if we did a small, large? So it's a database of multiple projects saved on this portfolio page. You can easily go in and add other projects to that database just by adding them there. And just to give you an idea of the file format, so the portfolio file is just, again, made up of a series of individual facility files. You can create separate groups, like only looking at agriculture facilities or commercial, institutional, etc. And just to help you manage your facilities, we also have built in the big map in terms of helping you manage your portfolio. So for example, you can see the projects in Ontario here. We can see what facility is up there. It's an elementary school that they're working on, or you can zoom in Ontario, for example, plastics factory, things like that. So it's a great management tool that way to visualize your entire asset pool. So we have pension funds, universities, industrial manufacturers, school boards, etc., hospital networks that are using RETScreen in this way. All right, we're beta testing with a number of these different organizations. So that's on the portfolio side. So that's essentially your database of all your projects or facilities, and then you can actually go in a what's called a new dashboard worksheet and actually do an analysis of your entire portfolio. So, for example, on the screen here, we could be looking at for example, we were doing a feasibility analysis before. So let's look at commercial institutional buildings. So the key information is summarized here. How much fuel consumption for each of the buildings here. You see down the left menu here how much fuel consumption base case proposed and how much saved, the fuel cost savings, the greenhouse gas emissions, and your key parameters such as how much it costs, the simple payback, and internal rates of return. And then that data is shown graphically here. So I can scroll the bar down. So we see the hospital, for example, the base case versus proposed case system. This is showing just the total energy consumption. So that can show you that if you're looking for a large quantity of savings, or you can modify this graph and say, well, no, actually, I'm interested from an energy use intensity perspective. So I click go here, and it'll actually tell you on a square meter basis which facilities are actually consuming a lot per square meter. And you can see now in this case, it's the quick service restaurants or full service restaurants. And there's some other nice features in there that you can show quickly. So, for example, you might want to look at which ones give you the best internal rates of return on your equity. So you can target, if you're doing an investment over an entire portfolio of facilities, which ones do you want to focus on first? So showing that the high school and the hospital have the two highest returns on investment. So it shows you how you can use this to manage your portfolio. And I'm just showing the feasibility analysis, but you can also, of course, do it for performance analysis and what is the ongoing savings and consumption and greenhouse gas use, etc. Okay, and of course that's linked into to an automatic reporting tool as well, just like the feasibility analysis. Okay.
Great, thanks, Greg. Very interesting. The next question is: can we use this model, or can we use the software for industrial process heating at a hot water of 90 degrees centigrade?
Yes. So so process heat. So you could use a virtual energy analyzer and go in and take one of our industrial examples that way. We also, for those that have used RETScreen in the past, we also have case studies and templates. So, for example, heat recovery, for example, in a brewery or a petrochemical plant. So if I double-click on here, it'll open it up. So this is essentially an individual measure for an industrial facility, and I'll go in after and look at. So it's process steam. You can go in and set your flow rates and your temperatures, etc. All right, and you can go in and look at process electricity, steam losses, the whole bit. Okay, so it's you can do very sophisticated analysis that way as well.
Okay, and the next question is: can this model be used for a solar cooling system?
Yeah. So yeah, it can. We're actually in the process of installing a solar absorption cooling system, sorry, an ejector cooling system on our roof of our facility at our lab in Montreal. You can do it. You would probably need to do it. We don't have a direct model for solar cooling yet because we tend to focus primarily on commercially available technologies that are widely used, but we add technologies over time. The way you do it probably is you'd probably do it as an absorption cooling system, depending on the technology you're using, and you assume the amount of heat that's actually available from your solar system. So you can do it. That one you contact us, we can show you how to do it. Because it's a bit more complicated because it tends to be a sort of one-off system. Okay.
Okay, thanks. Great. Another question is coming. I would like to see an example of using the software for monitoring and verification for a building.
Okay, yeah. So that in itself could be a whole other webinar. But let's. So when we're talking measurement and verification, we're really talking about the RETScreen, the performance analysis module. And this is where you do monitoring on an ongoing basis, and measurement verification is a very specific term used under different protocols for verifying that you actually get performance, the actual performance versus predictive performance of your measures. So RETScreen will do that automatically for you. So probably the best way to do that would be go into our case studies again, and I'm going to look at. I'm sorting by analysis type here. So we have some examples that you can look at. So and so I'm going to take a performance analysis for a small office building here in Canada. This is a built-in example. So given the amount of time left, I won't go into any detail here, but just to show you how you can look at it. So you can go into our case studies and template section, but it's the same look and feel. The location, this is in northern Canada, northern British Columbia, and the facility page are the same. There's the building we're looking at, and the difference is now the worksheets at the top, data and analytics. If I click on all, you're going to see the other sheets that we were looking at before, energy costs, finance, emission. But to keep the analysis more simplified, we're going to look at the data. And so this is essentially the database. And I click on, so we have some natural gas information there. This is the actual consumption, and then we calculate the heating degree days for the exact same time period. And this is where you do it sets you up for doing regression analysis, where you take your actual consumption, for example, versus a factor of influence such as the weather, like heating degree days, etc. Then you use that data and do analytics. And this is where you do things like regression analysis, where you're trying to create a predictive model given certain temperatures, etc. And then out of those analysis, you can create automatically in the software measurement verification graphs, which is a standardized graph. So the software, so just quickly to show you, so this is given the historical and baseline information. This is the consumption, the baseline year consumption of the building for natural gas. And if you did nothing to that building, in this case, this building, there was a high efficiency boiler put in, a gas boiler. So if they'd done nothing, the blue line, given the heating degree days, the outdoor temperature, this is what you would expected the consumption to be, the blue line. The green line, as you see when the project was actually implemented, is what the actual consumption was after and the area between those two curves is actually your energy savings. So that's a standard measurement and verification graph. The software does that for you automatically. And then of course the same reporting features are built in, and you can see it's all automatically built into the report, including all the graphs, etc., and the data if you want to see the data as well. Okay? So I think we still have time for another round of questions.
Yeah, there's one question related to that what you just showed, Greg. How does RETScreen verification implementation compare to the International Performance Measurement and Verification Protocol standards?
Yeah, so great question. So what I'm showing you here is we developed this with this organization. It's called EVO. I think it's Energy Evaluation Organization. Who developed the IP MVP, as it's called. This is the standard for doing measurement verification. So we actually developed it with them. Econolair International was the company that worked with us, who was on the EVO board, and we validated and tested it, and they've done training. So this is developed within that standard, specifically for it. So and they validated it versus the standard. So this graph was done specifically for IP MVP. And on top of that, we're also working with organizations who are using RETScreen for ISO 5001 energy management standard, which is excellent, and also now looking at the superior energy performance standard in the US for industrial. We're also looking to make sure the software is compatible with those standards as well. So we're fully integrated with our users in these sorts of standards.
Great. Thanks, Greg. A couple more questions. I think we have time for one or two more quick ones here. The question here is, the emission reduction calculation, is it as per the UNFCCC methodology, the CDM mechanism?
Yes. Okay. So that's a good question. So, so let me just load a building here first. I'm just loading any building from our virtual energy analyzer. Yeah. So we actually worked with the UNFCCC, primarily through originally through the United Nations Environment Program and their Resource Center in Denmark, and then with the World Bank's Prototype Carbon Fund. And so yes, we developed this tool with them. The emissions factors that are reported into the UNFCCC for each country. We validate them with the GHG protocol, for example, and we also might have some additional national numbers like for each province in Canada, the US, or for each state in the US. But it's done within the UNFCCC. And for example, and there are within the UNFCCC, I'm just opening the manual here, for example, for solar water heating projects, RETScreen is actually the tool required under the CDM to be used to do your CDM project. So not only are we integrated with them, and in some cases RETScreen is actually the required software tool to be used under a CDM project, for example. Okay. And I'll just show you while we're on that, because we have built-in electricity factors and and for various types of fuels, and also again, as part of our work with the UN, you can also go in and do a more detailed emissions analysis, and you can see the IPCC emissions numbers above, but you can go in. This is one of the requirements that the UNFCCC required for us, and the World Bank, is that you can do a marginal analysis as well and go in and actually change the mix of your grid and even change your baseline. This is also another requirement, being able to change your baseline in a certain year, for example. So yeah, so you can get very detailed and even go in and customize and do a level 3 and actually customize your emissions factors as well. Okay.
Great, thanks a lot, Greg. There's a couple more questions, but I think we don't have time. They're a little more detailed, so we can get to those questions. We can respond to them afterwards. It's just about 11:25 now, so we're right on time. I think at this time I'm going to pass it back over to CESC and ask them to conclude, and as well I believe they have a brief audience survey.
Thank you so much, Dinesh. And yes, we'll be able to export the question log and get answers after the webinar concludes for the questions we didn't get to. Right now, we have a brief survey that we would like to issue. Just one moment. Right now, if you could please select the first, select an answer for the first question showing up on your screen. The webinar content provided me with useful information and insight. Thank you. The second question on your screen, the webinar's presenters were effective. Thank you. Our next question, overall the webinar met my expectations. Our fourth question, do you anticipate using the information presented in this webinar directly in your work and/or organization? Thank you so much. And our last question, do you anticipate applying the information presented to develop or revise policies or programs in your country of focus? Great. Thank you all so much for answering our survey. On behalf of the Clean Energy Solutions Center, I'd like to extend a thank you to all of our expert panelists and to our attendees for participating in today's webinar. We've had a great audience and we really appreciate your time. I invite our attendees to check the Solutions Center website if you would like to view the slides and listen to a recording of today's presentations as well as any previously held webinar. Additionally, you'll find information on upcoming webinars and other training events. We're now posting the webinar recordings to the Clean Energy Solutions Center YouTube channel, and please allow about a week for that to be posted. We also invite you to inform your colleagues and those in your networks about the Solutions Center resources and services, including no-cost policy support. Have a great rest of your day, and we hope to see you at future Clean Energy Solutions Center events. This concludes our webinar.